Oh, hi guys. So, welcome to the stream. So today, I already did part 1 already. That was kind of more trial run though. Today, I'm going to be doing the differentiation and the integration for the CSEC Maths paper that's coming up next week. So, I'm just going to start sharing my screen now. Okay, can you guys see the screen? Hold on. Let me go and look in the chat. Welcome to the stream. Okay, so I'm gonna get right into it. So this is just differentiation and integration. All right, so this is June 2012. Ooh, this one's too thin. Okay, June 2012. So that's to differentiate this expression with respect to x. That isn't working. Okay, 3x plus 4 over x minus 2. I want to find dy dx of this entire thing. So how do I do that? This is something, a term divided by another term. So it's a quotient, right? So we're going to use the quotient rule. So the quotient rule is basically v du dx minus u dv dx all over v squared. Sorry guys, I wasn't showing you on the screen. Okay. So from this term over here, I have to let u equal to the top term and v equal to the second term. X, which is x minus 2. Now I'm going to differentiate each of these terms. So this is du dx, and this is just 3. Now I'm differentiating dv dx, and x minus 2 is really 1x minus 2. So then dv dx of this is just 1. I'm pretty sure. Yes. So now let's plug in all of these values. This value, this value, this value, and this value. Let's plug it in all here. All over v squared. So that's x minus 2 squared. So I'm just going to simplify the top, and you can leave the bottom as it is because it's factorized already. You don't want to expand that. So I'm going to use the distributive law over here. I kind of wrote it backwards because that's the order it's in, but you could write it like this as well, by the way. So it's 3x minus 6. So this is just 1, so you can kind of ignore that. And then just, this is negative 1. But people just use the minus sign and they don't put the negative 1 because it's kind of understood. So I'm going to use the distributive law again and expand. I'm really trying to be careful here and not do any nonsense, like, or make any mistakes. Yeah. So So this is 3x minus 3x, which is just nothing. And then minus 6 minus 4 is minus 10 over x minus 2 squared. So that is the answer. Should be the answer. Okay, next question is the point P. Oh, hold on. I need to bring it across here. The point P lies on the curve y is equal to 3x squared plus 5x plus 12, minus 12. Sorry. Find the equations for the tangent to the curve and the normal to the curve. So an important thing about tangents and normals is that they are perpendicular to each other. Which just mean they meet at 90 degrees. All right, so let's get into this question. Y is equal to 3x squared plus 5x minus 12. So as soon as I hear find the equation, an equation of a line. So the tangents and the normals, they are all, those are straight lines. And if I want to find the equations, I need a point on the line, which I have already, which is 210. And then I would also need the gradients. When I hear the word gradient and I'm on question 5, that immediately means differentiation. So I'm going to differentiate this. dy dx is equal to, well, you take this 2 over here. I think we should know how to differentiate. So this is basically 6x plus 5. If you all want an in-depth tutorial on how to differentiate, let me know. But oh, when will you be going live again? Maybe tomorrow evening. So yeah. Whoa, there's people here. Hi guys, welcome to the stream. Okay. So this over here, the dy dx, this is the gradient of the tangent at a point. This gives the gradient of a tangent at any point. So part 1, so I want the equation of the tangent at P. So first, I'm going to start off by saying that the equation of any line, any straight line, this is called the slope-intercept form. Y minus y1 is equal to m by x minus x1, where, well, m is the gradient. So using going to be using, so first I want to find the equation of the tangent, so I need to get a gradient. At the point P is equal to 210, x is equal to 2. X is equal to 2. So I'm going to substitute x into dy dx. Six x plus 5, which is 12 plus 5, which is 17. So I'm gonna go I'm using the gradient. Gradient is equal to 17, and the point P210, the equation of the tangent, you just substitute the value into this slope-intercept form. Right, so this is x1, this is y1. X minus 2. So now we're gonna fling the negative 10 across on the other side and flip the sign. And in the end, I get y is equal to 17x plus 24. Yes. Now the second part says I want to find the equation of the normal at the same point. So keyword here is normal. So the normal is perpendicular or at 90 degrees to the tangent. So the gradient of the normal at the point, let's call this m2 is equal to negative 1 over, well, m1, which is the gradient of the tangent. Negative 1 over 17. Now I'm going to say, using this new gradient, and oh, hold on, screen cut off. I'm using the new gradient that I got, and I'm going to use the same point to calculate the equation of the tangent. Normal, sorry. This can also be kind of confusing because when you're doing circle geometry, which is section 2, they would usually ask you to find the gradient of the normal, then the tangent. So that could be a little confusing. Y minus y1 is equal to x minus x1. And personally, I think I said this in my last stream, I don't like working with fractions because it just looks kind of tacky. And CSEC actually accepts this the format where it's just all whole numbers. So I'm going to multiply this entire thing by 17. If you're still here and you're still watching this video, do me a favor and press like on that video, please. And you can also hit subscribe. And this is the equation of the normal. Next question. The length of the side of a square is increasing at a rate of 4 centimeters per second. Find the rate of increase of the area when the length of the side is 5 centimeters. So this is something called rate of change. So the rate, this is 4 centimeters per second. 4 centimeters per second. So centimeters per second really means CMS minus 1. Right, so it's basically it's the same thing. Just put it throw it in the denominator. So this is the length over time. So let me see this question again. I want to find. I like to say RTF, which means required to find the rate of change of area, or rate of increase of the area. Okay. So I'm going to let the area be represented by capital E. All right. One of these kind of questions in a little while. So basically, you're kind of using the chain rule. So this is the rate of increase of length, because there's centimeters, right? So let's call the length L, and I'm gonna call this dl dt. As soon as you see the word rate, the rate of change, it's always with respect to time. So like the acceleration of an object is the rate of change of velocity with respect to time. It's always with something with respect to time. So they say that this is it a square? Yes, it's a square. And I want area. So I'm going to find area of a square. What's the formula for area of a square? Side by side, also called side squared. Area. Okay, let's just call it length. Length by length, area is equal to length squared. So I'm going to say something called dA dL. I'm going to differentiate this. So this is 2L. I want the rate of increase of area. Which is hold on. Yeah, dA, I want dA dt. So what I'm going to do, I'm going to say dA dt. I'm just going to like basically kind of multiply both of them. So this one has the dA on the top, so I'm going to leave it like that, dA dL. And this one has the dt on the bottom. So I'm going to multiply minus by dL dt. And it basically cancels out. So then you get dA dt. So that's proof that we have the terms in the correct order. So now we substitute. Go back. This is our L, guys. That's our L. So dA dL over here is, I said it was 2L, and dL dt is 4. So I'm going to substitute 4 into here. So I want to say when L is equal, let's go back. When the length of the side is 5, so L is equal to 5. Where is my note? Right. L is equal to 5, dA dt is equal to 2 by 5 multiplied by 4. This is 10 by 4, which is equal to 40. Don't forget your units. This is cm squared s minus 1. Thank you for the likes, everyone. Hi, welcome to the stream. Okay. Next question. This is the integration question now. Oh, I'm good. How are you? You came here to learn something. Anyways, guys, so this is a definite integral. What does that mean? I'm not answering that. This means that there are fixed limits of the area that I want to find. This is number 6, A. Which is our integration question. All right. Let's write that down. Hold in here. All right. So I want to evaluate this. So what I would do, I'm going to use this formula. Hold on. Okay. All right. I was just double checking the formula. So if I want to integrate something that looks like ax plus b raised to the power of something, let's call it n, then basically what I'm doing, I'm just going to take the bracket ax plus b, I'm going to add 1 to it, n plus 1, and then I'm going to put this all over the a from the bracket and multiply by the n plus 1 up here, n plus 1. Okay, so I'm just going to substitute these values in. Yeah, right, in CXC, I am. I'm actually preparing for the AdMaths exam next week, Tuesday. Anybody here who's writing that exam next week, good luck. Y'all are going to do so good. Oh. Okay, adjust our camera right there. All right. So 16 minus 7x. 3 plus 1 is 4. And then I'm going to take the 16 and multiply by the 4. I'm going to put all of this in brackets since it is a definite integral. I'm going to put this number right here, which is 1 at the bottom, and the upper limit, which is 2, on top here. Right. So you could leave it in this form. So this is kind of like a function. So for a definite integral, I'm going to take this number and I'm going to plug it into here. And then I'm going to subtract that and I'm going to plug this value into it. Let's go. So wherever you see x, You put this value in first time. 16 minus 7. Whenever you see an x, you put 2. Hope I'm not doing nonsense right now. I didn't make a little careless mistake. So power 4 all over. You could simplify this. 16 by 4 is 64. So I'll just put that there. Over 64. Then I'm going to put minus sign and write back the term. And wherever I see an x, I'm going to put in my lower limit. Now, it's just like a function. Negative 7. No, n is the power. N is the power. So it'll be 3 plus 1 is 4. Because 2 is the upper limit. This is the question. Yeah, this is the question. Do I? Oh, no, it's raised to a power. It's not dy dx of 16 minus 7x. All of this is raised to a certain power, 3. It's raised to a power 3. Hold on. Let me pull it up. Raised to the power 3. Okay. So we can plug all of this into our calculator. So we're going to do right now. So this is 16 minus 7 by 2. 2 to the 4 over 64. Now I have 9 to the power 4. Sixteen over 64 minus 6561 over 64. Let's plug that in. Oh, this is interesting. And I got negative 6564 over 64. Hold on. Guys, I'm gonna be I'll come back in like 1 minute. I'm just gonna double check something to make sure I didn't do nonsense. Okay. Let's scan this problem here. I just asked in ChatGPT. What? Oh my! It didn't scan properly. In the integral, you divide by okay. It was reversed. Yeah, guys. Yeah. Let me go and do that over. Yes, guys. You are right. Yeah, when I got a negative answer, I was like, nah, something wrong. So this could really tie up a lot of people. Because it's not in the order ax plus b. Yeah. Thank you. So I'm going to actually rewrite this so it will fit the format. Negative 7x plus 16 to the power 3 dx. That was my bad. I literally wrote it on my board and it's, yeah, anyways. So taking this, I'm gonna add 1. Then I'm gonna take the negative 7. That's the a. So ax plus b, and then I'm multiplying by the 4. And so our limits, and let's do this real this time. Negative 7x plus 16 to the 4 over 28. I did nonsense. 7x plus 16 over negative 28. Okay. Negative 7 by 2 plus 16. Oh, it worked. Okay. 2 to the 4 over 28. Yeah, 28. And I've taken away 1 plus 16. 9 to the 4 over 28. Negative 2. Right, negative 28. Nine to the 4th power. 6561 over negative 28. Take this away from what ChatGPT telling me something different. Two to the 4, that's 16 minus 28. Take away. I do not. 60. Yeah, I have the negative sign. Multiples. Thank you so much. I'm getting 935 over 4. My ChatGPT telling me something different. Yes. So, yeah, guys. Yes. Great. Okay, next one is this point lies on the curve. So I'm just gonna write on. I like to write down the information that I get. So I just like extract the information from the question so I could like map it out in my head. So I want to find the equation of the curve. I just write down the information so y'all could see it because like with this technology that I like just found today, I can't show the thing at the same time. So if I have dy dx, so I want to get y. So I'm basically going to get y, I'm going to integrate this. And this is an indefinite integral. So we should not ever forget the plus c. Plus c. So how do I find the plus c? I need to use this point over here. So q. So at the point q, x is equal to 4 and y is equal to 8. So I'm going to substitute those values into my yes, I got that too. Oh, you divide. Right. So 8 is equal to 3. Yeah. So c is equal to 4. So hence the equation of the curve y is equal to whatever I just wrote there, and I just put it in the c. So this is my equation of the curve. Usually, another follow-up question they like to ask is to like find the area on the curve, and it's usually the same curve, so you have to integrate again. Okay. Part C says to calculate the area between what? Oh, all right. I thought it was asking you to find the area between two different curves. Okay. Okay, guys, I'm back. So this is my curve, the x-axis, and then these are my limits. You find a space. You're going to fail. No, you're not. Don't say that. Oh, a great website to check out is fastpassmaths.com. It has all the solutions for CSEC, AdMaths, and CSEC Maths. Well, I know the paper gone already, but you still have some time between now and then to fix whatever things. Oh, um, Caribbean Secondary Education Certificate. That's what it stands for. It's basic. Is that's the exam that people that Form 5 people does, right? And I'm going to write AdMaths next week, which is kind of scary. Okay. Thanks. That's amazing. Yeah, you're gonna do amazing. Oh, I was looking in the chat and I forgot the question. Wow, really? That's really cool. Um, how was it? Was it like scary? Like GCE 8 hours. Whoa, wait, that's nice. Okay, I'm just writing down the question. Right. Um. Okay. Right. That's what we do. So I'm finding the area. So I need to put units squared. That's really important. So if I'm integrating cosine x, I'm gonna get, wait, I have it on my board. It's negative sine x plus c. But since it's a definite integral with limits, that means um, I don't need to have the plus c. If it was indefinite, that means I have to have my plus c. Oh, oops, I forgot the x. Sine x dx. Cosine x plus c. Right, so with this in mind, I am going to plug that in. Okay, so it's just like the other one. It's like a function, so I'm just going to plug in my values. I'm going to plug in the upper limit, which is pi over 3 every time I see x. And then I'm going to minus it from, I'm going to go study for your exams. Okay, bye. Thanks for stopping by. Thank you. Same to you. 0 plus 3 cosine 0. So sine. So don't forget, when you're working with pi, that automatically means radians. So you have to have your calculator in radians. Oh, what am I doing? Plus 3 cosine of that, cosine of pi over 3. This is a half. Alright. As sine 0 is just 0, so you just put it there. And this is 3 by 1, which is just 3. Okay. What? Oh no, I do nonsense somewhere. Where did I do nonsense? I integrated, I put that there. Wait. Cosine is negative sine, sine is cosine. Yeah. Okay. I did that right. Negative 2 sine. Yeah. What nonsense I do? I don't. I have a 3. It's a half. That's 3 halves. And then I've taken away the. I think I went wrong somewhere. I'm gonna ask ChatGPT again. Okay. When I finish this paper, cos x integral is sine x. Was that serious? Oh my gosh. This is yeah guys, I did not eat for like a few hours. This is what it does. So guys, don't forget to eat, because you can make careless mistakes. Just like me. This is not really a revision course, guys. This is kind of like a study with me. So I think I mixed it up for the differentiation and the integration. Yeah. Agreed. But I'm in Form 5, like that's what they call it in my country. I think that's like grade 11 or grade, hold on, let me search it. Yeah, I'm in grade 11. Let me write this over. Yes, it is. Okay, so I'm gonna integrate it and then I'm gonna plug in my values properly this time. 2 sine x. Oh, I mean, this is for plus c, but that's if it was an indefinite integral. Since this is a definite integral with limits, then I don't need to put that. Cos x is sine x, and for sine x, it's negative cos x. So, okay. So now I'm going to plug in my values. 3 cosine. Two sine 0, take away 3 cosine 0. So this is 2 by root 3 over 2, should be, minus 3 by a half. 2 sine 0, this is just 0. And then minus 3 cosine 0 is 3. 2.96. Okay, alright. Yeah, I get it. Was area. Did I do the same thing? No, I didn't. No, it's okay. I do some nonsense before, and now I'll fix my mistake. So that should be 3.23 units squared. Let's see. You want to ask chat? Yes. So units squared. Or you just put square units as well. I'm just gonna finish out this paper and then I'm gonna end the live. There's one more question left. So this one says calculate the volume of the solid. So this is volume of the solid of revolution. So our curve is y is equal to x squared plus 2 x-axis, and then my limits are x is equal to 0 and x is equal to 3, and it's rotated. So the formula for the volume of solid of revolution integrated first of all. Of course. So I'm just gonna write down my formula for the volume of solid of revolution. Yeah. So I like to put the pi outside here. I have my two limits, and then y squared dx. So I like to take this and see what is y squared. It's just this, all that is squared. Message retracted. Wait, why did that do that? Sorry, I can't see a message. So x4 plus yeah, I'm gonna integrate. Where is the people? Okay. X is equal to 0 and x is equal to 3. Am I doing nonsense? Sorry. Oh my gosh. No. Then put my limits. Well, I was trying to type. I'm not seeing your message. I don't know. It's saying message retracted, and I don't know why. Oh. Okay. Well, I don't even need to do all these zeros because it's everything just gonna multiply to be 0. Yes, it is 96.6 cube units. So units cubed. And that is the differentiation and the integration and the differentiation for the June 2012 paper. So if you haven't already, please hit the like button and the subscribe button. And thank you guys for coming to the live. I hope you guys learned something and you guys were able to do some revision. And yeah, bye guys.